All right, here we go with the key for exam 1. And I'll show you my rubric 2 in terms of what I'm looking for. So if you have questions after you look at this and you can't figure out, why did I get the score I got? Then let me know and we'll meet up and we'll go over it. Okay, so the following data represents the average number of hours a week a random sample of students, of 40 college students spend online. So we've got all of this data. So what I did is I said, look, what's the minimum value, what's the maximum value? So I've got the maximum value was 29, the minimum was 13.4. So I said, 29 minus 13.4 is about, let's see, 7 plus 9, it's about 16, approximately. And then I divided by 7, because I wanted to look into making 7 classes. So if I do 16 divided by 7, I get 2.2. So I made my class widths 2. Now you could make them 3 if you wanted. If you start making them bigger than that, then the data's clumped together too much. So here we've got hours online and number of students. And I'm going to start at 13 and just go by 2s. 15, 17, 19, 21. And then I'm going to just go ahead and put my data into these categories. And let's go up here. I've got 2, 4, 6, 8, 10, 12, 14. So between 13 up to 15, but not including 15, there were 8. And then there were 7 between 15 and 17. And then go up to 12. 19 to 21, there were 4. 5. 23 to 25, there were 2. 25, 27, I had 1. And then 29 to 31, there was 1. Okay, so this is worth 4 points. And basically, basically what I was looking for is 2 points for making sure that you label it, and 2 points for drawing a good histogram with a good scale, okay? I think actually if you didn't label it, I probably just counted 1 point for that. So 1 point for the labeling, and then 3 points for the histogram itself as well as the scale. This is a number line. This is not 13 to 15, 15 to 17. That's not a histogram. A histogram is, this is a number line. If you put them in groups like this, then you have to ask the question, well, where is the 15? Okay, and this looks more like a bar chart instead of a histogram. Okay, so which measure center should you use and why? I'm going to use the median, since the data is skewed. 2 points, because the mean is affected by the skew. The mean gets pulled out that way. Describe the distribution. The distribution of time online is, and I wanted to look for 4 things is what I was looking for. The total were 3 points. It's skewed to the right. You have to have context. I want to know what it is. Don't tell me the graph is skewed right. Tell me what is skewed to the right. Skewed right, possible outlier of 29. The center is about, and we're just looking for approximations here because we're just kind of roughly describing it, and spread from 13.4 to 29. Okay, so I'm just looking for these. Basically, when I graded this, I'm looking for that you at least included 2 of these on here to get full points. But if you just said skewed, you're gonna miss a couple of points, right? Okay, so next page. I said 29 students, algebra course, time in minutes, make a diagram. So the one that I chose to make, a lot of you guys made dot plots, which is fine. I happen to make a box plot, so I just did 0, 10, 20, 30, 40, 50, and 60, and actually I'm actually going to do a dot plot. So this is time on homework. You got to include that, you guys, because otherwise it doesn't make sense. So this is worth 4 points as well. To draw, you need to have a scale, you need to have a label, and then whatever it is you drew. I did a box plot because I put the data in my calculator and found it went from 8 up to 15 up to 32.5. And if you draw this to scale, then you get to see the skewness of this 22, or slight skewness, I should say, 15, 8, 32.5, and 51. Okay, I want you to find the mean and standard deviation of this, and this is, put this in your calculator. So the mean and notation, x bar, because it's a sample, that's why I underlined it, is 24.4. And the standard deviation is S for sample, sigma is population, 11.9, and that was 4 points, 1 point for each answer, so what I looked at. How does what does standard deviation measure in the context of this problem? It measures the average. It's not exactly the average, but it's really close to it. That's why I put it in quotes, deviation from the mean minutes spent on homework. Okay. And in this case, is standard deviation a good choice used to measure spread? And the answer is no, since the data appears skewed. If the data is skewed, then the mean and standard deviation are not good numbers, or not good measures to use for the center and spread. Okay, 3, list of customers, list of the number of customers waiting for a table at 6 o'clock on 40 consecutive Saturdays. Find the 5-number summary. So you have to write these in order, and I'm not going to do all, well, actually, maybe I will here. 5. Mm-hmm. 13, 14, trying to squeeze it all in. So you want to find the 5-number summary, so you're looking for where's the middle, and the middle is right here, that's the median. And then you find the median of the bottom half. Don't include the median though. So then that becomes, here is Q1, the minimum. Q3 is way up here at 10. Again, it's halfway, and then the max. So the 5-number summary would be 3, 6, 8, 10, and 14. Right, halfway between 8 and 8 is 8. Halfway between 6 and 6 is 6. The first quartile, Q1, is 6. So that tells me 25, or there were 6 or fewer customers waiting for a table 25% of the time. Okay, context, guys. So 25% of the time there was 6 or fewer. Those guys right there, approximately 25, right? What is the IQR? What does it say? IQR is Q3 minus Q1, which is 10 minus 6, which is 4. And so what does it tell us context? That's the range, how far it is from here to here, right? How long is that distance? The range of the middle 50% of the numbers of customers waiting at 6 p.m. Okay, are there any outliers? Outliers, how do we do that? Well, we look at Q1, we look at the lower fence. Oh, sorry, grading. This is worth 4 points up here. 2 points for this, 2 points for this. Basically 1 point for the value, 1 point for the explanation, 1 point for the value, explanation. So for outliers, it was Q1, the lower fence is minus 1.5 IQR, which if you do that, you get 0. And the upper fence is Q3 plus 1.5 times the IQR, which is 16. And if you just said no outliers, you would lose a point. This is 3 points here. I need you to explain, to say since all the data is between 0 and 16, there are no outliers. Okay, number 4, got a bunch of data here. Okay, looks like the chirps per second is being affected by the temperature, so it's being explained by the temperature. So that would be the temperature. Scatter plot, this is the number of chirps per second. This is the temperature. And if you do this, just kind of try to make it sort of close. I'm not going to plot them, I'm just going to show you kind of what it looks like. Something sort of like that. Okay, so this is +2. This is +3. Basically having them grouped right there and then a point for having it labeled. Assuming the data is approximately linear, state the least squares regression line. So if you did this on your calculator, you should get y hat equals 0.212x minus 0.309. That's the equation of this line of best fit. And the correlation coefficient, which again your calculator does for you, is 0.84, where x is the temperature and y is the number of chirps per second. Those are 3 points. Basically, I look at 1, 2, 3 points. Describe the association. The association between temperature and chirps per second is linear, strong, or moderately strong because R is 0.84, positive, without outliers. Okay, so that's what I was looking for. That was worth 2 points. If you had just 2 of these, then I gave you full credit. State and interpret the slope. Okay, the slope is this number, the coefficient of x, 0.212, and what that means is on average. Because it's 2.2 over 1, right? And the units are y over x, so it's chirps per second over degrees Fahrenheit. So on average, for an increase of 1 degree Fahrenheit, there is an increase of 0.212 chirps per second. Okay, and that was worth 3. 2 for this, the explanation, and 1 for that. How many chirps per second would you expect? That's 0.212 times 80 minus 0.309. You plug it in there, you get 16.7 chirps per second. Some of you guys just gave me ranges, and I probably was okay with that, but I want you to calculate it. And that's 2 points, and the last one is 2 points. It's a serious study found that people with 2 cars live longer than people who own 1 car. 3 cars is better. There's a substantial positive association between the number of cars and the length of life. Okay, so number of cars, length of life, they're saying it's positive. Can we say owning more cars causes one to live longer? No. No, we cannot say causation from an association. Just because there's association doesn't mean this causes that. For example, wealth might lead to both. Right? You might have more cars if you're wealthier. You might live longer just because you have more access to medical care or whatever. So that's 2 points. So the whole test overall was basically, it ended up being 50 points. So times 2 gives you your percent. Okay, there you go on that. And again, check it out. If you have any questions, let me know.